Hello students. In this video, we are going to discuss about two topics. First one is how do metals and non-metals react, and the next is corrosion. How do metals and non-metals react? We know that atoms of all elements need 8 electrons in their outermost shell for their stability. In a reaction between a metal and a non-metal, metal attain its stability by donating electron while non-metal do so by accepting electron. When metals react with non-metals, electrons are transferred from the metal atom to the non-metal atom forming ions and the resulting compounds are called ionic compound. Here is the sum of the examples for the ionic compounds. Sodium react with chlorine forming sodium chloride. Magnesium react with chlorine forming magnesium chloride and calcium react with oxygen forming calcium oxide. In these examples, sodium, magnesium and calcium are the metals and chlorine and oxygen are the nonmetals. Formation of sodium chloride. We know that atomic number of sodium is 11 and its electronic configuration is 281. So, sodium atom has one electron in its outermost shell, and if it loses the one electron from its outermost shell and attains stable octet, sodium gets positive charge on it. That is sodium cation. On the other hand, chlorine has 7 electrons in its outermost shell and it requires one more electron to complete its octet. After gaining one electron from sodium, chlorine atom gets a unit negative charge. This gives chloride anion. Sodium and chloride ions, being oppositively charged, attract each other and are held together by strong electrostatic force of attraction to exist as sodium chloride. Note that it does not exist as a molecule but aggregates of oppositively charged ions. Then formation of magnesium chloride. The atomic number of magnesium is 12 and its electronic configuration is 282. It has two valence electrons and it loses two electrons to form Mg2 plus ion. The atomic number of chlorine is 17 and its electronic configuration is 287. As in the previous case, it has 7 valence electrons and it gains 1 electron to form Cl minus ion. Then the attraction between Mg2 plus ion and two chloride ions result in the formation of magnesium chloride molecule, that is MgCl2. In all of these reactions, the metal atom give electron to the non-metal atom and the metal atom become positive ions and non-metal atom become negative ions. There is a strong electrostatic force of attraction between the oppositively charged ions and this is called an ionic bond. Then we look at some of the properties of ionic compounds. First one is ionic compounds are hard and brittle. It is because of the strong force of attraction between positive and negative ions. Second property is they have high melting and boiling point. This is because considerable amount of energy is required to break the strong interionic attraction. And they are generally soluble in water but insoluble in solvents such as kerosene, petrol, etc. Ionic compounds in solid state do not conduct electricity because movement of ion is not possible due to its rigid structure. But in the molten state, the ions become able to move and they conduct electricity in its molten state. Next is corrosion. Corrosion is basically an electrochemical process and it involves the chemical destruction of a metal as a result of its reaction with gases, moisture which is present in the environment. Examples for corrosion are corrosion of iron which is known as rusting, That is, iron, when exposed to moist air for a long time, it acquires a coating of brown substance which is known as rust. The next is tarnishing of silver. Silver article, when exposed to air, it reacts with sulfur to form a black coating of silver sulfide. And copper react with carbon dioxide in air and it loses its shiny appearance on the surface to form a green coating. It is basically copper carbonate. Some of the methods used to prevent corrosion of metals are given here. To prevent corrosion, metal surface is protected from its surrounding by coating it with paint, oil or grease. This method is also known as barrier protection. The next is galvanization. Galvanization is protecting steel and iron by coating them with a thin layer of zinc. The next method is alloying. This method is explained with a simple example. Pure iron is soft and it is not used in its pure state. But if it is mixed with small amount of carbon, it becomes hard and strong. Or when it is mixed with nickel and chromium, we get stainless steel which is also hard and it does not rust. That is, alloying is a process of changing the properties of a metal by mixing them with some other substance. Next method for the prevention of corrosion is by electroplating. That is, coating a less reactive metal like chromium. Thank you.